Hello, everyone. This is the second of our a couple review videos from Algebra 1 and Systems of Equations for our Algebra 2 class. This is for the week of April 27th, 2020. And this particular video will be on solving by substitution. So again, a little bit of review of Algebra 1, but we're dealing with systems, which we know is two equations that we're going to be able to solve, hopefully, for a solution. So in this particular case, I want to kind of talk about when would it be best to use the substitution method. So we would suggest here that the substitution method might be best when at least one of our two equations is either already solved for one of the variables, or it's really easy to see that one of the variables is able to be solved. So again, what we're taking a look at here is we're going to have two equations. It's a system in this situation as our review for Algebra 1. And out of our two equations, at least one of them, could be both, at least one of the equations, it will be either already solved for one particular variable, or we could take a look at the equation and say maybe one move would be able to solve, get one of the variables by itself. So there's nothing saying that we couldn't use the substitution method for every single problem that we see. Maybe it's your particular favorite one. I'm not sure about that. However, it is definitely something to consider when these situations pop up, that we see one specific variable either already solved for or very easy to get by itself. So we're going to check out two examples here. Should be relatively similar to something that you might have seen back in Algebra 1. But in this particular example here, you can see negative 3x minus 3y is equal to 3, and then y is equal to negative 5x minus 17. The first thing that I would notice here is that there is no coordinate plane here for this example, so I could go ahead and create one myself. However, that might be a good hint to not necessarily graph this. The other thing I want to check out here is that I have two equations for this system. They're both linear. I got negative 3x minus 3y is equal to 3. This equation right here is in standard form, which might be something that kind of is a callback to Algebra 1. And then this right here, the second one, is in slope-intercept form, where we know that we have our y is equal to mx plus b. It's kind of one of the things that probably was something that rattled off very much so in Algebra 1 class. So the big thing here is that what I'm really focused on is that I have in the second equation the y already by itself. Since that variable is already by itself, it would be extremely simple for us to take what that y is equal to and substitute it into the other equation in order to solve for one of the variables. And in this case, we're going to be solving for x. It doesn't have to be the y that's isolated, although if it's in slope-intercept form, we see y is equal to mx plus b. The y is by itself. So in this case, it really lines up for us really well to substitute something in for y. So I'm going to go ahead, I'm going to rewrite the first equation here. And knowing what I know about the second equation, that y being by itself, I'm going to, wherever I see the letter y, That's the letter that's isolated. I'm going to plug in what y is equal to in that second equation. You know me, I like to use parentheses when I plug things in. So I'm going to go ahead and use parentheses here. And I'll plug in negative 5x minus 17, which was what was equal to y in the second equation. And then I'm back to kind of rewriting out the first equation. And I have to put that equal to 3 on the back end. Now I'm just doing some algebra here and just using good usage of all the properties that I have here. I'm going to go ahead and distribute negative 3. Do have to be careful, that is a negative 3 there. So negative 3 times negative 5x would actually be positive 15x. Negative 3 times negative 17 would actually be positive 51. And we're still equal to 3. And again, I'm going through this process now. I'm going to combine like terms on the left side. And hopefully this is all just a little bit of review for you. I'm going to subtract 51 to both sides, that inverse operation, get negative 48, divide by 12, and we get x is equal to negative 4. Now hopefully this is the second of a couple of videos you're going to watch this week, and hopefully this is just kind of rehashing some things that you learned from Algebra 1, but more importantly, you knew from the first video on graphing that if we had two lines drawn up on a graph, a lot of the time we would see them intersecting at one specific point. So I do have an x value here, which is fantastic. Great job, everyone, for solving that. However, we do need to make sure that we plug and actually substitute that x back into one of our equations in order to get the y, because we need a point as a solution to this system. So I'm going to go ahead, I'm going to plug it. It doesn't really matter which one I actually do it for. However, it might make sense for us to use the second equation because it's already solved for y. So since it's already solved for y, we just go ahead and plug what we know about for x right now, and we should be able to do this rather quickly. So I take that x out, I'm going to plug the negative 4 we just learned about in there. Negative times a negative is a positive. And I get that y is equal to 3. I got x is equal to negative 4. I got y is equal to 3. Okay, we do want to make sure we sum this up by actually writing it out as points. So the solution to this system of equation, and we know that there's only going to be one of them, would be the point at negative 4, comma 3 as our final answer here. Next up, I have this second set of equations, and we can kind of look here that we are now kind of maneuvering ourselves out of dealing with something in slope-intercept form, that y is equal to mx plus b. I actually do have two equations here where they're both in standard form, which is not a big deal. Be able to work with it here. And again, we do want to try to practice solving this system of equations by substitution method. So we know that for a substitution method, we're looking for one particular equation with one particular variable where it would be very, very easy to isolate that particular variable. And I have the coefficients here for all the variables. I have up at the top negative 7x, negative 2y. And then on the bottom, I have an x and a minus 2y. The coefficient there for the x would be the number 1. And that's kind of something that we want to pick out. Even if I didn't write that number 1 in, you can kind of see that the x is kind of just sitting there by itself, or at least we would only have to do one maneuver, one inverse operation in order to get the x by itself. And I'm going to go ahead and do that. So I'm going to take this equation here in the second equation. I'm going to add 2y to both sides. 11 plus 2y, not possible. Just go ahead and rewrite the thing. So I got x is equal to, make it actually look like an x. I got x is equal to 2y plus 11. Not slope-intercept form, the x is by itself, but again, the important thing here is that the variable is by itself. And now I can go ahead and substitute that into the other equation. So there's my isolated variable. That's what it's equal to. I can go ahead and plug that in. So I'm going to rewrite out the first equation now. And I'll go ahead and substitute what I know for x in for x. So there's my -7. Here comes the x. And I'll go back to my first equation and fill that out. And again, just like before, now I'm using all my properties of solving an equation in order to do this correctly. I got to distribute here to start off with. So I distribute, and I want to combine like terms on the same side. -14y minus 2y, those are 14 negatives. There's 2 more negatives, that's a total of 16 negatives. And I'm going to run out of room here, but I'm down to solving a 2-step equation. And I have -16y is equal to -13 plus 77 would be 64, positive. We'll divide both sides by -16, and we'll get y is equal to -4. It's great that we were able to do all that math work. We substituted in what we eventually got, x by itself. We were able to substitute in 2y plus 11 into the first equation to get y is equal to -4. However, we need to go get the x value for this because we know that if it's a solution to this system of equations, it's going to cross at a point, and we need an x and a y value. So again, I need to go find x. It would probably be easiest to use that red equation that we wrote down right here in order to get x the quickest. So I'll rewrite that out. And I'll plug in what I now know, or substitute what I now know in for y, which is -4. And do a little math here. And I get x is equal to 3. We'll finish up the problem by writing out the solution as a point. So we know here that our solution would be the point value 3, comma, -4. So maybe not necessarily the easiest thing to graph for both of those equations and define the system that way. However, we were able to use the substitution method, and we know that if we had to draw these two lines, that they would cross at the point 3, -4.